A very warm greetings to everyone watching this video. I am Prasad Timande, student of Bapurao Deshmukh College of Engineering. This is my CO activity for M3 subject. In this video, we are going to discuss about eigenvalues and eigenvectors.
So let we move to our topic, that is eigenvalues and eigenvectors. It comes under the unit of matrices. If A is a square matrix of order n, then A minus lambda I is called as characteristic matrix, where lambda is a scalar. Scalar means it could be any number. The determinant of characteristic matrix is equated to 0, that is, the determinant of A minus lambda I is equals to 0. Then it is called as characteristic equation. The roots of characteristic equation are called as characteristic roots or latent roots, or we call eigenvalues. These eigenvalues have some properties. Let we discuss it in details. The sum of eigenvalues equals to the sum of diagonal elements, that is we called as trace of the matrix. The second property of eigenvalues is the product of eigenvalues equals to the determinant. Let if lambda is eigenvalue of A, A matrix, then the lambda square is eigenvalue of matrix A square. Again we suppose if lambda is eigenvalue of matrix A, then lambda inverse is the eigenvalue of matrix A inverse. The next property is set of eigenvalue is called as spectrum of A. The largest eigenvalue in magnitude is called as spectral radius of matrix A. Let we move to our next property, that is A and transpose of A. Our matrix A and its transpose has the same eigenvalues. We are also going to discuss some shortcut trick or formula for characteristic equation. If matrix A is of order 2 by 2, then its characteristic equation is lambda square minus s1 lambda plus determinant of A equals to 0. If the matrix A has the order 3 cross 3, then the characteristic equation will be lambda cube minus s1 lambda square plus s2 lambda minus determinant of matrix A equated to 0, where s1 equals s1 is the sum of diagonal elements, that is the trace of matrix, and s2 is the sum of minors of diagonal elements, and the determinant of A we have to calculate via calc. Let us discuss about eigenvectors. If x is a vector, it could be a row vector or a column vector having the entries x1, x2 up to the xn, is a non-zero vector such that A minus lambda I, that is characteristic matrix, into this vector is equated to 0. Then this x vector is called as eigenvector or characteristic vector or latent vector. Make a note that an eigenvector x cannot correspond to two eigenvalues. So let us take an example to clarify the eigenvalues and eigenvectors and how to solve it. So here in this example we are going to find the eigenvalues and eigenvectors of given matrix A. Our matrix A is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. So for this we are going to solve it. First of all, we are going to write characteristic matrix, that is A minus lambda I. So it could written as, first we have to write our matrix A, 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Minus lambda I. As we know that lambda into I, that is identity matrix, gives us the scalar multiplied to it. So we are going to directly write as lambda 0 0 0 lambda 0 0 0 lambda. Let us solve it. It becomes 8 minus lambda, minus 6 remain as it is, 2 remain as it is, minus 6 7 minus lambda. We have to subtract this matrix with this, and minus 4 remain as it is, 2 also remain as it is here, minus 4 also, and it becomes 3 minus lambda here. So it is our characteristic matrix. Now we have to write characteristic equation for 3 by 3 matrix, which is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equals to 0. Let we find out S1 and S2 first. So S1, that is sum of diagonal elements. So what is our diagonal elements? That is 8 plus 7 plus 3. That is our 18. This is what S1 is. Make it a box here so that we can identify it easily. Now S2. S2 is the sum of minors of diagonal elements. That is, first diagonal element is our 8. So we have to left this column and this row, and we have to find the determinant of these remaining elements. So 7 minus 4 and minus 4 3 plus next diagonal element is 7, so we have to left this middle row and this middle column. So x2 8 and 2 and 2 and 3 plus minor of our third diagonal element. For that we have to left this uh, third column and this third row. So 8 minus 6 and minus 6 7. Now we have to cross multiply these elements, and after finding the later on we have to add them. So 7 into 3, that is 21, minus 4 into minus 4, that is 16, plus 8 into 3, that is 24, minus 2 into 2, that is 4, plus 8 into 7, that is 56, minus 6 into minus 6, that is 36. After this calculation it is 45. So here we got S2. Again we have to make a box here. Now we are going to find out the determinant of A. For our convenience, we are going to use this scientific calci. So first set this calci into matrix mode. For this, go into mode, then 6 and then 1 mat A. Select 3 cross 3. Here the display shows the empty matrix. Here we have to fill our entries, that is elements. So 8 equals to minus 6 equals to 2 equals to minus 6 equals to 7 equals to minus 4 equals to 2 minus 4 and last element is 3. So after that we have to press AC, and then to find determinant we have to uh, do shift and 4. So here we get some options. From that we have to select the seventh option, which is determinant. Here we get determinant, and again we have to do the same, that is shift 4, and our entered matrix, that is mat A on third number, so 3. Close the braces, and here we got the answer, that is determinant of matrix A e- as 0. So note it down. Again put it into a box to note it easily. Now put this S1 and S2 in characteristic equation. So characteristic equation, that is our lambda 3 minus S1 lambda square plus S2 lambda minus determinant of A equals to 0. So lambda 3 minus S1 we have get as 18 into lambda square plus S2, that is 45 lambda minus determinant of A as 0 equated to 0. So that is lambda 3 minus 18 lambda square plus 45 lambda equated to 0. So now we have to put this into our calci. For that select mode, then fifth option equation, then the fourth option ax3 plus bx2 plus cx plus d equals to 0. So 4, what is a, that is 1, b, that is minus 18, c as 45, 0. Then we get our eigenvalues as 15, 3, and 0. These are our eigen values. For finding the eigenvectors, we have to consider, let x1 be the eigenvector for eigenvalue lambda equals to 0. Such that a minus lambda I, that is our characteristic equation, into eigenvector equated to 0. So it becomes, we have already calculated characteristic matrix into x1, x2, x3 equated to 0. So it becomes 8 minus lambda. We are calculating for lambda equals to 0, 8 minus 0 minus 6, 2, 6, 7 minus 0 minus 4, 2 minus 4, 3 minus 0 into x1, x2, x3 it becomes 8 minus 6, 2, 6, 7 minus 4, 2 minus 4, 3. It gives us equation that on multiplying, that is 8x1 minus 6x2 plus twice x3 equals to 0. Note it equation 1. Same with the next. After that, we have to apply Cramer's rule here. That is x1 upon minus 6, 2, 7 minus 4. x2 upon 8, 2 minus 6 minus 4, So we have to do just simple cross multiplication here. 24. Make note that here it is minus x2. Sometimes students neglect that negative sign. That is, so we have to further simplify it. Here we can cancel the negative sign. So we can directly write here it as x1 vector, that is x1 1 2 and 2. Here we have just uh, got the values of x1 as 10, x2 as 20 and x3 as 20, and uh, we have simplified it in the form of 1, 2 and 3, that is we have just divided. Same process we have to do with x2 vector. Here I am directly going to write the uh, eigen value in the place of lambda, so it becomes 8 minus 3 minus 6 2 minus 6 7 minus 3 minus 4 2 minus 4 and 3 minus 3. x1 x2 x3 equated with 0. So it becomes 5 minus 6 2 minus 6 4 minus 4 2 minus 4 and 0. Same thing we have to do here. We have to multiply this matrix with these eigen vectors. So we get 5x1 minus 6x2 plus 2x3 equals to 0. Mark it as equation 1. Then minus 6x1 plus 4x2 minus 4x3 equals to 0. Next 2x1 minus 4x2 plus 0x3. Here consider any two equations. Make to note that you should not forget to write this negative sign here. Oh, here it is 8 not 18. I have mistakenly written over there. X3. So here it becomes minus 2, minus 1 and 2. Again the same process for third eigenvector. So here for the third eigenvector I have directly already written the process. You can make note of it. We have just simply done whatever we have done with the last two eigenvectors. You can see over here. So uh, this is how we got our three eigenvectors. This is our third eigenvector. We can write this in another matrix. This both the eigenvectors we got. as the first eigenvector was our 1, 2, 2. The next was -2, -1 and 2, and the third we got as 2, -2 and 1. So, and this another matrix in which we write our eigenvectors is called as model matrix. So hope that you are clear with the topic of eigenvalues and eigenvectors. Thank you for watching this video.